Hello students, the purpose of this video is to provide you a quick tutorial on some of the points to note in preparation for Lab 6 to ensure you get all the grades you deserve and don't lose any unnecessarily. First of all, in preparation for the lab, make sure that you have available your textbook, some form of electronic calculator, scientific calculator. In this case, I have used my tablet calculator, but you can also use a personal one, your phone, or Excel. It doesn't hurt to also be sure to make reference to the rubric, which is provided to you on Blackboard, and the test data that I provided to you on Blackboard, which looks something like this. It has 3 tabs. The first one, left to right, is for a 200-pound vertical force. The second one is for a 500-pound vertical force. The third one for an 800-pound vertical force. Now this might be different for your individual lab, but in general terms, the vertical confining forces will be as just shown. Back to your textbook. So Lab 6 is outlined right here. You have all the relevant information here in terms of the tasks to carry out, a video demonstration, as well as some of the important points of the report. On the page after this, you have the 2 graphs that you need to produce. And also, this lab makes reference to this table, which you can find in your textbook as well. Now, you don't have to use this specific table. You'll notice, in fact, there aren't enough rows on this table to include all the measurements that I'm providing to you with your Excel file. But nonetheless, you can use the Excel file itself to reproduce this table. You have this data, and you have something similar to this in your Excel readouts. And you can simply reproduce all this stuff at the top with the information that's been provided to you. A few things to note. The very first one, which is a very important one, the shear force that's required to be inputted here for the purposes of calculating the shear stress, well, this shear force needs to be zeroed. Do you remember? The data that I provided to you doesn't start at 0 for zero displacement. It starts at some value, which means that you have to subtract the 0 force reading from all of these values to get the actual 0 force. So the first tip to note is make sure you zero the shear force. Next, when calculating the shear stress, make sure you use the zeroed shear force. And don't forget, what is the formula for shear stress? For stress in any form, it is a force divided by the area. So tip number 2, to ensure you get all the grades you deserve, is make sure you use the correct shear area. Okay? I'm pretty sure that I provided you what the dimensions were of the sand sample. There were something in the order of 2.35 inches by 2.35 inches long by wide times 1 inch high. Well, the shear area is this here, right? Because that's where the shear happens. That's the area along which the shear happens in the sample. So, notwithstanding the tasks that you're asked to carry out and some of the details of the report, in addition or in conjunction with what's required of the rubric, a few more notes about the graphs you're going to be expected to produce. This is a shear stress versus displacement. You have been provided with the displacement with the data. Make sure that the shear stress that you use has been zeroed, of course. And then here is what you're going to be producing are essentially going to be the equivalent of 3 graphs that more or less look something like this, say, more or less, where this one usually corresponds to the lowest vertical load. This one typically corresponds to the highest vertical load, and this one typically corresponds to the mid vertical load. So in our case, approximately 200 pounds, approximately 800 pounds, approximately 500 pounds or so. Now the shape of your graphs might be slightly different, but in general terms, this is what they're going to look like. Now going on to the second figure, second graph that you're going to be expected to produce. the Moore-Coulomb failure envelope, you'll actually be using this in your third year soil analysis course. You're going to be plotting shear strength versus affected normal stress. The shear strength is simply the maximum values that you get from this graph here. Okay, so it's going to be 3 values along the y-axis that correspond to the highest shear strength value you get from here. What is the easiest way to get these values? Well, since you're going to be plotting each one of these points, either in Excel or by hand, you can actually find these values in the long list of Excel data that you have, or that you've written out by hand. So that's going to correspond to 3 values along the y-axis. For the normal stress, you're simply going to divide each one of these 3 values in turn by the cross-sectional area of the sample, the normal area. Now, a reminder that the normal area in this case corresponds to this area here for the normal force. So if you take these 3 values in turn and divide them by the normal area, you'll get the values on the x-axis. And then you'll get some 3 points, and I'm just making them up. They'll look something like this, say, and you're going to plot the line of best fit going through 0 and figure out what that angle is. So just a reminder, if you provide this figure to me, I'll count it as a bonus. Thank you for your time.